today's DELMIA Foundation quick tip, we're going to talk about threaded holes and how we can take hole wizard information from SOLIDWORKS and pass it through for downstream applications like DELMIA. So what I have open here is SOLIDWORKS 2021, and there you'll find a setting in the hole wizard area that now allows data from the hole wizard to be passed through to the 3D Experience platform. If this checkbox is turned on, then what happens is when I save this data through our connector or through the 3D Experience SOLIDWORKS, when the physical product is created, we're now going to pass that hole wizard data information over to be used downstream. So if we look at our DELMIA Shop Floor Machining Shop Floor Programmer role, you'll notice that once that data is converted to the physical product, I now have that information that can be used. Now, one of the ways that this can be used is if we go to our PPR. When we run feature recognition, you'll now notice in feature recognition, when we identify the hole, it is a simple hole, but we now know the tap drill diameter, we know the depth, we know the thread diameter that needs to be used, thread depth, thread pitch, and the type of thread it's going to be, as well as, color, timestamp, flat bottom angle, all the good things that we need. But by passing that hole wizard data through with that checkbox, we're now getting a lot more information that can be used for machining processes or our rules-based machining. So if we look at how we're going to set that up, the first thing I did is, just because it's a quick tip, I went through and I created a simple tap here, and then I saved that tap to my catalog. So if I look at this here, and we look at our tap, here's our basic generic tap, here's a holder. This is a really quick example just to show that it's 3816. I put a nomenclature on it of 3816 UNC, and I did that more specifically because when we go to write the rule, we want to make sure that we're calling and looking for a 3816. So I'll briefly discuss the rules again. We do have a lesson on this, but rather than creating a generic one, I just popped in here, created a machining process, and then I created a section called tapping, and in this instance I want to do a spot drill, drill, and tap. So when I do my tooling query for tapping, what I'm doing is I'm looking for an assembly of a tap, and then I put in what information that I want that to contain, and then I can save that. So I can say, hey, when you're looking at inch tooling, I want you to look for a name, and that name has to contain 3816. If I move that up, then when I run my tap, it's actually going to look for a name that contains 3816. And I can set queries and checks on this also. So if I do edit checks here, I can say, hey, for this tapping instance, I want you to look in machining features. And if we go to our machinable axial feature, I want to look for the diameter to be equal to, so we'll do equal to 0.3125, because that's our tap drill diameter, right? And if I push that up, what it's going to do now is it's going to set this check, so if it sees a MAF feature that has a diameter of 0.3125, then we're going to put in a spot drill, drill, and a tap. And if I want to do spot drilling here, I'm going to pop over to my catalog quick and just look and see what I have for countersinks. So we'll see what I got in here for a countersink. Maybe I got one up at the top here. Oh, spot drill. I can do a 1/4 inch spot drill. So if I look in here, then in my query, I can say, hey, I want my query, instead of a cutting diameter of this, I want to remove that attribute. I want to look in here, and I want the name to be equal to we'll do 1/4 spot drill. We'll add that. And then in my tooling query here, we'll remove this and we'll put a name 5/16. And I'll say I want that to contain that. And I should probably set this one also to contain. So we'll move that down to the bottom. Or we'll just create another one here quick. So we'll do name contains, and I'll just do quarter. Okay. And then once we have these queries set, I can also come into what should be fair is I should set the operation as well. So that way on my strategy, I'm picking the type of approach that I want, my feed in, lead out, all those good settings for how I want drilling to work. So in drilling, for example, let's say on strategy, I want to do a dwell with break chips. We'll hit OK. And then when I'm ready to save this, I'll just go ahead and send it to a catalog. And I'm going to update an existing catalog that I have. And you can put your tools and your rules together in one catalog. I keep mine separate because sometimes I want to do different things. I can also link different rules to different catalogs. The sky's the limit on how you want to set that up. So with the catalog saved, now we can go ahead and invoke those and run it and do a test. And again, once I set this up and it's stored in a catalog and it works the way I want, it's there. I can just run the rule and let it work on any part that's there. This is sort of giving you a little bit of the nitty-gritty setup and testing, but keep in mind, once the rule is created, it shows up in this list, and then I can simply go to any part, run feature recognition, tell it where I want to put it, pick the rule, hit OK, and it'll go through and do what it needs to do. So you can make these rules way more complex than this. This is just showing one quick example. Once it's ran, you'll notice that it puts in a spot drill, a drill, and a tap. Also put in the correct tool change, and you'll see that it grabbed a 1/4 inch spot drill. It grabbed 15/16, more than likely because I mistyped. I just told it to grab a specific drill. In the future, I'll go back and change that rule. And then it puts in a tapping operation here. So if I were to now calculate these toolpaths and run it, it automatically put that in. Now, if I had a bunch of holes on this plate that are different sizes, different taps, I can have it run through, look at every feature that was found in the feature recognition, and then it'll go through and automatically assign all of this, saving me time and clicks. So keep in mind that you can set this stuff up once, it can be more automatic, but the very cool thing that is now available is the tapped information or the whole wizard information from SOLIDWORKS can be used downstream inside of DELMIA to enhance the operations that we need and streamline our process. And just like I mentioned before, here I made a typo. No big deal. I can always go through and change that and update those rules. I can manually change it on the fly if I wanted to. Here, or instead of 15/16 drill, I can say, hey, I want to use a 5/16. But to change the rules, it's just really a tool query coming in here. And since I said contains, I probably should have typed this out a little bit more to be more specific. So it found a 15/16 instead of a 5/16. I can just change that rule and make it more detailed. But when I'm done, I just do send a catalog, update the catalog, and the rules there to run. And if you look in my list, here I can make it more specific. So when I look at that 5/16 drill, I can come up here and call it a 5/16 drill. And if I say it has to be this specific name, then that's what it'll grab. If I give it a diameter range, then it'll find a diameter range. Rules are really what you make of it and how open or closed you want it to be. But the cool thing is you can make it whatever you want. You can also set a whole bunch of operations to be achieved in one shot with these rules. This is just more of the basic, center drill approach that we've done in the past, for a lot of things that we do in machining.